My name is Omar Basiso. I run a company called Thought Design. About 7 years ago, I started Thought Design to do architecture services for software. People called me crazy, and they said, who creates an architecture company? People usually create software development companies, and on the back of that, sell developers on higher rates, and they call them architects, right? So I ended up in the last 5 years now, traveling a bit around the world. So anywhere from Budapest, Kuwait, UAE, New Zealand, Malaysia, Thailand, consulting around the architecture and meeting with different clients. And the talk today is about the story, the findings of my travels and dealing with different architects on a day-to-day basis. Well, let me start with this. So the usual thing is you say to yourself, okay, eventually I want to become an architect. Is that the case? Is that the case that every developer is going to eventually become an architect? Is that a natural progression? Hands up who thinks it is. Okay. So everyone here is an architect. So this is the reaction you get from people. I want to become an architect. People say, are you crazy? It's a lot of responsibility. No one knows how to define what that job even is. And it's only good when you get a pay rise. So as a developer, you're a developer for 4 years, then automatically you become an architect. That's exactly like the bricklayer in a construction company becoming a civil engineer in 4 years. Not to belittle the developer's job, just saying that's the analogy. And I found that the most reason why people sort of hate architects and start giving them terms like ivory tower architect and doesn't know what he's talking about and believes that he can design the world is because they think of this guy. They usually think that an architect will draw some boxes and some arrows on a whiteboard and say to the developers, go, implement, make it happen. And whatever I designed without validating or prototyping, but look how pretty it looks on the whiteboard, it must work, go for it. And that perception was the problem. So let's establish then what the architect needs to do. What skill sets does he need to have? Or the misconception around what skill sets the architect needs to have. So who thinks an architect here needs to know lots of technologies? Okay. Shout out who thinks technology is more important than design. Okay, design is more important, I'm guessing everyone? Right. So this is my problem. People think that the architect needs to be a master of all technologies. In fact, who in their company also uses the term full stack developer? Yeah? Does that work out for you guys? Do you find this guy who can do JavaScript as well as exactly as good as he can do T-SQL? An expert of both? I'm reading these skill sets on Seek these days, and I'm looking, okay, so the full stack developers needs to know JavaScript, Gulp, Grunt, HTML5, CSS3, HTTP2. He needs to know how to interact with JavaScript frameworks and use JavaScript frameworks, binding frameworks like Knockout, signaling frameworks like SignalR, Angular, Angular 2, and the story goes on. That same developer needs to also know C#, object orientation, design patterns. He needs to know how to talk to SQL, ADO.NET, ASP.NET, MVC6, etc., etc. Let alone the .NET Core guys, which you need to know that as well. He needs to know Azure. He needs to know deployments. He needs to know databases. He needs to know indexing. He needs to know stored procedures, views, index views, etc. So, to me, this sounds like a job for Superman, right? If you expect people to know all of that, which part of that are they going to be good in? So, moving forward, those same people, you look at the design, and the same people produce a design like this. Now, this might be artistic. I want to hang it up in my home. Might not be very good for software, right? But because we lack the science to produce such design. Who knows what the common science for producing software today is? Come on, guys, we've all done it at some stage. Right? This is the science. Right? If it's in Stack Overflow, it must be correct. And the result of that science is spaghetti code. Right? So what are the challenges of the architect? What does the architect need to solve? Let's try to dissect it down. So there's people and dealing with people. There's process, and there's design. Now, why do you think the AKA engineering is up there? Because funnily enough, we call ourselves software engineers, yet we're the only engineering discipline on the planet where you can practice without acquiring a license. That's why you end up with a lot of people going for a 3-day HTML course and then having on their resume, senior web developer, right? That's why we're one of the few industries in the world where after we do a deployment, we publish a release, they don't ask us about the quality of the release just lightly. You know, if it was a car, it'll be, has it passed the safety checks? Yes. Has it been through the QA department? Yes. In the software industry, has it been through the QA department? Yes. How many bugs do you have? It's not, do you have any bugs? It's by default. How many bugs do you have? Right? It's almost assumed that whatever engineering we practice is always going to produce a flawed product. Right? And technology is important as well. Even that is important, but it's just to validate your design, and we'll talk about that in a little bit. So let's take these points one by one. By the way, I just want to comment. With people, you get other people that can do that with you, to manage people, to deal with people. You get HR, you get project managers, you get scrum masters, you get managers, etc. People are part of your responsibility, but they're not fully your responsibility. With process, same concept. You get scrum masters, you get project managers, they use waterfall, scrum, Kanban, all that beautiful stuff. You get shared responsibility. What you don't get shared responsibility around is design. As an architect, your most important responsibility is design. Can you design a solution? And by the way, I'm talking about solution architects here. Enterprise architects, they need different kind of medication. Sorry if anyone here is. But yeah, I'm not alienating the crowd at all. So let's go to people. So who are the people we deal with? Let's identify the personas that we deal with. So there's this dude, the customer, the product owner, the guy who blabs requirements at you all the time, the project manager, the scrum master, the stakeholder, the software development manager. Hey, Omar, I need you on this project. No, I need you on that project. Come on, this has become a priority. The client phoned up and he said, we have a bug by default. And then there's you. All right? Sad story. It'll get better. So how do I deal with people? Clarity and precision. So as an architect, you need to be able to articulate the problems to the different personas in your team, within your stakeholders. You need to be able to talk to people and make the message very clear, whether you're gathering requirements and trying to explain to them why those requirements need to be prioritized in a certain way, or when you're talking to your team and you're discussing solutions and you tell them about why certain components need to be built the way that you're explaining. Conviction, please have the knowledge to back what you say up. You can't have the ego, let's say, and I can't believe I'm saying the word ego among architects, but they have ego that says, I'm right anyway, and if I don't know it, I'll just blab some stuff and look like I know it, right? Transparency. One of the most common things I hear with architects is that I told them what they needed to know. Who's used that one before? Don't be shy. I told them what they needed to know. Now that's a problem. You need to portray the full story. Telling them what they need to know means that you could not explain the full story, right? Honesty. If you get it wrong, if you get your design wrong, communicate it to your team, communicate it to your project manager. Tell them, well, it was a design, we're wrong, we're going to fix it, we're going to do something about it. Again, ego plays a big part here, where, no, my design is always correct. I've created a framework, no one can beat it. All right? Link them up. Link the personas up. Link those characters up. Link this Scrum Master, the stakeholder, the developers. Create a ubiquitous language. Those who do domain-driven design must have heard about a ubiquitous language and how you need to create a language which can explain the problem, the solution, the maintenance plan on many levels. Right? So what is a good example of that? And at the end of this, hopefully it'll make more sense. Who here reads anything about biotech? Have you ever heard about mycelium? So this is very interesting. Mycelium is a fungus that basically, let's say there is a tree over here growing in a place which lacks nitrogen. And there's another tree 10 kilometers away which has nitrogen. Mycelium as a fungus grows on the ground, creating a network between both trees. And what it does is this tree has got a lot of nitrogen, this one doesn't. It grabs some of the nitrogen, passes it to the next tree. It creates this network beautifully across obstacles and across all that sort of stuff. So in Japan, they use mycelium, for example, to create the rail network and to manage to find the best path to get the nutrition across to the plants, etc. They modeled the same thing with the railway network on how should we do this, bypassing the obstacles. So if you learned anything today, and feel free to tweet it, Omar Basiso says, to be an architect, you have to act like fungus. Okay? Process. So who does this at their workplace? No Scrum practitioners? Oh, we've got one. Well, it's kind of hard. You teach Scrum. Yeah. So if you're not using Scrum, you're using Waterfall? What are you using? Cowboy. So my problem with processes, again, across the different companies I worked for, I see that process becomes something that enslaves the team members. It's not an empowerment anymore. It's not an organization technique. It becomes an enslaver. People think that if you apply this, your project is going to succeed by default. Stakeholders think that if you apply this, you're always going to come under budget and you're always going to have clarity around where your software is going. So, as software developers here today, who can yell out, what is the best process management technique? And not Richard, because he's a Scrum Master, so difference there. So can we establish that there isn't the one silver bullet that will get you where you want to get you, like regardless of your problem, right? Process, just like design, just like your practices, just like your development, need to react to the requirements and nature of the project, right? So where you decide that? In project planning. You sit with your team, you sit with your stakeholders, you take in the inputs. What's our budget looking like, right? Are we like the Scrum guys and we think the world is an endless budget where we can keep slipping all the time? We'll do it in the next sprint. We didn't get to it in the next sprint. There's a deadline, 4 sprints later. Or we do what the waterfall guys do and say, I want to change the color on this button. That will be a 20 grand change request, thank you. So what do we do? Sit with your team. Know who you're working with. Know your constraints, know your environment. Know what the people around you need and what your environment entails. And that's the way you come up with a process. Right? Now, that's the team's process, the general process of developing the software, but there's the architect's process itself. We refer to this process as the 33%. Yes, again, if you want to tweet another quote, Omar said, if you're doing less than 33% of design work on a project, you're not doing it right. You're most probably just coding. So what's the architect's process? Number one, design. That's what you do. That's what you do. That's your main job. If someone asks you, what does an architect do? Design. All right? Prototype. Make sure that your design actually looks like something. Make sure that you actually make it work. Get feedback. Ask your fellow architects, ask developers. You know, once I noticed this as well, that once someone gets named an architect, he looks at developers as inferior beings, right? Oh, you don't talk to me, I am the architect. And I blame The Matrix for that, right? Anyone watch The Matrix? Right? The architect at the end, who knows all. And test. Test, test, and test. So let's get into the crux of it. What I want to discuss next is some of the design process and what are some of the design techniques I found, and discuss these a little bit. So, we've agreed that solution design is exact engineering, so you need to use engineering disciplines. If I ask anyone here today to yell at me, what science do you use when you model software? Sorry? Yeah, so what was the first thing you said? Yep, okay. Yep, but within that, can you describe the science, the techniques, etc.? I'll bring you up here. Okay, and I'm not suggesting that at all, but I'm saying UML again is a tool. No, I'm not suggesting, I'm saying that if you ask many of the people today, what science are you using, right? What did you base your design on? The answer you would get usually is crickets, right? In fact, many of the people I speak to, they say most of our application is CRUD. Fair enough. What do? He goes, well, I go into my controller and I call the stored procedure directly using ADO.NET and I wrap it all within the transaction. That is actually called transaction script. That actually has a name, right? I just model every screen to a table. That can be called active record. That actually has a name. So what science are you using, right? So let's find a bit of where the basics are, and that is component design. Essentially what you're doing is dividing and conquering. You're getting requirements, you have a big problem, and you start dividing and conquering, creating components, services, objects, microservices, Lego blocks, whatever you want to call them. You are creating software components, right? So when creating these software components, what is the default assumption that you're going to make? What does your customer usually do mid-project? Change requirements. How many of you complained about this again and again? I can't have this, it's Wednesday, it's mid-sprint. He can't change the requirements mid-sprint, right? In fact, how did your argument work? Did it actually fire back? Did your manager say, yes, the client is wrong, we will fire the client, you're correct? Did that ever work? Right? So the reality is, change is something that is there. It is the constant. We have to adopt it, we have to just accept it as reality and build stuff that is responsive to change. So number one, your job is to design. Number two, whatever you design needs to be responsive to change. Change that you're aware of today, change that you can predict with a probability, and change that you don't even remotely think about, right? Now, you got to be practical, right? So if you're working in a CRM company and you want an extra feature to manage, emails with clients, great. But if you are a pharmaceutical and you want to turn into a kebab shop, we have a problem, right? Not that type of change. Now, decomposition. Who's done layered decomposition before? 3-tier, N-tier, 2-tier, I-tier, U-tier. Yeah? Cool. Is that decomposition? Is that decomposing the problem? Isn't that more of an infrastructural technique where you say, I'm going to put my UI at the top and my data at the bottom and some stuff between them to, justify my job? Functional. I call this client-driven architecture. So I'm sitting with the client, and the client is saying, hello, by the way, I want a user, and the user needs to jump on a website. He needs to register. He needs to log in. He needs to look at the product catalog. And once in the product catalog, he needs to be able to check some of the products into a cart and check out and do payments, etc. Now, here is what your brain is doing in that meeting. Your brain is like customer table, user table, payment table, transaction table, product table, right? Oh, crap, I missed a foreign key. Yeah, there's a foreign key from customer to order, right? That is customer-driven architecture, right? That's your customer doing the architecture for you. I'm not saying it's wrong, just to be very clear. These are all decomposition techniques. I'm just going to propose something else at the end. So, configuration. How many of you ran into companies where you got there and they said, we want to build everything very modular and plug-in models this, and I want to be able to change one key in the config file, and it will turn from a standard to an enterprise version in no time. It's all configurable, it's all add-ins, it's all this, it's all that. Yeah. Did that ever work? No? Okay. So, skills. Who's heard about the skills-driven architecture? I've got two great database guys. My business logic is in the stored procs. I've got people who are fantastic in C#. I'm going to go do my ETL using C#. I've got great UI guys. This is my favorite. This is the trend. Business logic in JavaScript. Or as I call it, the devil's food. Hey, Krispy Kreme uses that for donuts as well, so let's not get very, very sensitive. So what is the decomposition methodology we're going to use? So let's go back to what we said. Change is the only constant. Change is what's going to happen. You, as an architect, need to create a sort of predictive analysis in your head for what could change, what might change, and how to cater for change that you don't know. And for that, we use volatility decomposition. Volatility decomposition means that you decompose stuff by the probability of these components changing and analyzing if the change does happen. How hard will it be to replace the component? How hard will it be to amend it? How hard will it be to add extra functionality, remove functionality, change database schemas? So volatility decomposition is very important. So let's look at some of the techniques we can use under that. Who's heard about this one before? Yeah? Most of the OO guys familiar with it? Now, it's Valentine's, and I thought, what's better than to explain the message of high cohesion and low coupling with a message of love, right? So, high cohesion, right? Let's not bring anyone between us. Let's keep it that. We belong together. We need to be together as a unit to be functional. We're beautiful together, right? Low coupling, fair enough. Was that too much? Was it Valentine's Day? I thought might as well explain the message with love. So I'm by the way, not leaving all the questions to the end. Do you have any question up to this point? Or shall we continue? Okay. So, high cohesion, low coupling. Get your objects, get your components which belong together to stay together. Those which do not belong together should not have a dependency defined between them that then stops you from upgrading one without the other, deploying one without the other, managing change in one without the other. All right? Design patterns. Sure you guys have worked with these before at university. Does anyone these days, like how many of you guys are actually active coders, active everyday coders? Right. What do the rest do? Anyway, sorry. So from my perspective, when I code, I look, am I actually adhering to the design patterns? When I say they figured it out and I will get paid for it, that's exactly what happened. I mean, the Gang of Four created the science, saying here are the design patterns, here are the patterns that will help you make your code adaptable to change. You can use a bridge, you can use an adapter, you use a strategy, and you're going to make things beautiful, right, in terms of responding to change when it happens. But what did we do? It was a university course. You learn it, you let it go when you get your certificate. Right? So it's all about going back to basics. The solid design patterns. Who knows those? As architects, you simply need to know those. Not only because it helps you design solutions, but also because it helps you talk to clients. It helps you find ways to explain to clients solutions on a business level. Why? Because when you say single responsibility principle, what does it mean to a developer? It means I'm going to create a class, a module, a method that does the one thing. What does it mean to a customer? We're going to take your functionality, we're going to create it here, and we're not going to make it dependent on anything. It's going to do the one thing, and it's going to do it really good, right? And it's that one functionality. When we talk about open-closed principle, right? What does that mean? It means your class is open for extension and closed for modification. It means your functionality really, once coded, should not change. An example for that is if you are today accessing a database without any type of caching, and then your customer comes and says, hey, the speed on this is not very good. Can you enhance the speed? And then you want to roll out caching. You shouldn't be really touching the code which you wrote in the first place to deal with the database. You should be incrementing functionality without touching the existing code. What does this mean to your customer? Hello, dear customer, you know that piece of code that we've developed for you and it's currently working? We're not going to charge you another $10,000 to go and regression test everything because we basically bastardized the code. Liskov substitution principle, maybe do not speak to your customers about this one. It's a bit funky, but for the techos, you know, it's basically that your base classes and your classes have got to, and your base components for that matter, and your components are going to act, when passed through a certain service or operation, they got to behave the same way. Interface segregation principle. So when we buy laptops in Australia, we basically get these brick power chargers, right? And you get an Australian cable. Now, when you go to London, what do you need? You just need the cable, right? You need the cable. You don't need a whole power adapter. You don't need another transformer. You just need the cable. It's the same thing. How many of you guys now these days think that the PayPal way of doing stuff has taken over and people say, I'm going to develop one REST API and everything is going to talk to it. My product has got an API. You can talk to it from a mobile, from a Windows application, from a Java application. It doesn't really matter. It's one API. Right, so my question usually, and this is what comes up in enterprises, doesn't come up much with PayPal, but PayPal's story is different. But with enterprises, what if the mobile security scheme is actually different to that from the Windows application or anything else? How do you respond to that? You need the same core, different exposures of functionality. And dependency in Virgin, well, if you're not doing it, I'd say, I'll borrow from Nike here and say, just do it. Right? So, again, back to the question of what science do you use? And this is where my science comes in. I found that software is becoming more complex, software is becoming more data intensive, and I found that I have a book. It's not a religious book, but I have a book. I have a manifest that I can follow that decomposes different parts of my software, gives it names, gives the exercises names, gives the layers names. If I want an entity representing a real life object, I've got said, I've got entities. If I want descriptors, I've got value objects. If I want exposed APIs, I've got application services. If I want to create an integration between contexts and between different components in my design, they're called context maps. It gave a definition to everything. It gave a definition and gave a way to decompose my problems. Right? Then after that, after this became my science, I started finding some nice techniques. One of them, Richard spoke about this morning in his talk, in CQRS. I mean, we keep hyping on about singular responsibility principles and doing stuff properly, etc. But your major problem at the moment is that your reads and writes are always mixed. Most of the stuff I see on a daily basis when I go to clients is basically no separation between what DBAs would call the third normal form and the first normal form. In fact, sometimes I'm lucky if developers in a place that I visit know what's the difference between the third normal form and the first normal form. Now, even DBAs will tell you, by the way, if you are writing and if you've got a heavy write processes and very intense sort of data pumping into the system, you're better using the third normal form, no data replication, redundancy, etc., etc. But if you want to read really fast, if you're an Amazon, a Stack Overflow, or you are an eBay, then you want to read from databases with the first normal form. Not too many joins, nothing crazy. You want to pump data out as fast as possible. So DBAs have told us this about 20 years ago. But us as architects and as developers of applications, we always thought, too much code. Yeah. Another thing we've done. Who here does data modeling? Cool. Who here starts an application off, regardless of what that application is, by creating a database schema? Okay, who here has done it in the past? Now, the question is, could we have used that to solve anything? Any problem that gets thrown at us? The problem is we always thought of it this way, that go to the MSDN articles, go to the Sun Microsystem, Java tutorials, and what you'll get is screen, relational database, and some guff in between to tie them up. All right? Now, this was interesting. So the turning point in my life, and I won't mention the client's name, unfortunately, but I got into a place that says, okay, you're going to be capturing financial data from Bloomberg as a source and from Reuters as a source, and you're going to be getting 183 data points to collect per second. All right? So I started thinking about immutability, about the fact that this resembles an event, about queuing, about thinking of these problems differently. It's not a glorified Excel application, Access application anymore. It's not a glorified Excel worksheet. It's actually doing solution design. All right? And for that, I borrowed this image from Martin Kleppmann, which basically says how LinkedIn created their kind of data processing for their scenario. So everything that happens on LinkedIn through profiles, profile changes, connecting with people, posting a resume, making a comment, endorsing someone for a skill he doesn't have, all of that sort of stuff, right, has been created as event streams, right? So instead of foreign keys and tables and primary keys and, in this and date time to this and all of that, no. We're going to take everything that happens in real life as an event, and we're going to create an event stream out of it. Then out of those event streams, we're going to create projections. We're going to take ETL processes and take the streams and create some kind of data warehouse. We're going to take the event streams and create some caching for our website. We're going to take the event streams and create some pumps into other systems consuming our event streams, into other components within that ecosystem. That is class. That is thinking outside the box. And you know what's the sad part? It's a technique that's been with us for 30 years. But we got so engulfed in the relational database world that we forgot to learn other techniques. I'm not telling you that to go tomorrow, delete all your projects and start event sourcing. But what I'm saying is that there are other techniques that should help you with that. Should help you with your problems, sorry. Now, who here follows the Martin Fowler blog? Okay. Now, what happens to you emotionally when Martin Fowler posts a new blog post or a new buzzword? Because I have a problem with one of them. Who here has attended talks so far to hearing about microservices and what they do? So, my problem with this is that it is not new. It is not an architecture technique. In fact, it's nothing except taking something that exists and saying that we're going to manage it, develop it, maintain it, and deploy it independently. So, some people would ask, what's the difference between microservices and SOA? Who here has spent 10 years of their career working with SOA, service-oriented architecture? So what did you get? You got services that not necessarily got developed. You called it services, and sometimes the deployment of these services was into a monolith by nature. You tried to create as much boundaries within your domain as much as you possibly can, and you released it out, and you said, this was my best attempt at it. Now, because most of your attempts were lousy, excuse me, what happened is that Martin decided that I'm going to go there, I'm going to say, let's create clear boundaries for these contexts and these components, and I'm going to deploy them and manage them and get developers who manage them independently. Now, as an architect, you have to be very careful from buzzwords. Who remembers light switch? Do you use light switch? Why? Who remembers Google Wave? Do you use Google Wave? Well, if you said yes, it'll be really weird. But so, who remembers that beautiful thing in .NET called datasets? Type datasets. Do you still use them? So. Right. So, again, buzzwords are a problem. If we had these basics, if we thought with design patterns, we thought with domain-driven design, we thought with science, data sets back then would have not made sense. Light switch would have just alienate you as an architect, right? Service bus. Who here uses service bus in general? Right. Do you mind me asking, when did you start using it? Yep, how long ago? Last year is no problem. My problem was more like 5-6 years ago. N-Service Bus was the hot thing. And you had a monolith, the components talking to each other, but they want to raise events. Let's send them over to the bus and have a subscriber within the same process go to the bus and get the stuff. Why? Because it's buzzword. It wasn't the solution for the problem, but we had to have it. Right? We had to have it. JavaScript frameworks. Who here thinks, except Paul Glavich, of course, that JavaScript or most applications need to all be rendered on the client now, by default? And let me ask the question another way. Who thinks that there is no place for server rendering web applications in 2017? But it doesn't matter. See, the decisions with your clients are being taken is because Angular is the new hot thing, or Angular 2 is the new hot thing. It's not taken based on science. It's not taken based on architecture. That's your job. Your job is to educate and say, this will not work for this scenario. You need to think about it. Right? Now, let's talk about some other stuff. Integration patterns. So we're building more and more distributed systems. By nature, you take something like microservices, now you're building a distributed system, you've got more problems. Integration patterns. Who here has worked in a company where the integration patterns were actually set before the project started? Okay. Couple? So what do you think happens when you start a project and then you decide later how you're going to integrate with other systems? No, nothing? No one experienced that? Like, sorry? You get spaghetti. Nice. Mighty mess. And how do you solve that? Throw a bus at it. All right, so infrastructure. As architects, that was our main thing. Also, as software architects especially, we usually say, I don't need to know anything about this. It's someone else's problem. How is that working out for you with the movement to the cloud? So your infrastructure guys, are they still getting your packages and deploying it and everything goes hunky-dory? Do you find yourself training them up? Do you find yourself involved in the pipeline of deployment? Right? So again, we can't run away from infrastructure anymore. I'm not saying that we need to all go get our MCTSs or MSCE or whatever the certification is called, or become all like infrastructure gurus. I'm just saying you need to know some infrastructure. You can't run away from that anymore. All right? DevOps. So who here has a DevOps department in their company? Okay. We've got a DevOps story. Okay. So CDA, and what else? Anyone doing like DevOps as a first-class citizen in your process? Ooh. So again, gone are the days where we go to the procurement manager and say, I want 65 grand to buy this brand new HP server. I want to put it in the data center. Today is its first day. I'm going to run Windows Update and I'm going to put my antivirus and do everything I can possibly do. Tomorrow, I deploy my app. After tomorrow, that server becomes sacred. You cannot possibly run Windows Update on it. What if Microsoft breaks something? Hey man, I want to install something, and this server is sitting there, it's only running one app. No, we don't know what would break if you would touch it. Right? That's not a DevOps story anymore. We're in the virtualization world, we're in the cloud world. Never deploy to the same server again twice. Create recipes. Use Chef, use Puppet, use Octopus, use whatever you want to use. Create recipes. Deploy a different server every time. It's really cheap now. For some people, it costs nothing. Then switch your IPs when you're ready. Not only does that give you efficiency, but it also gives you zero downtime. Well, as close to zero downtime as possible. Right? Have a DevOps story. Invest in DevOps. It will help you out in the long run. If you don't have CI, CD, release management today, you need to. As an architect, you need to assist your whatever project you're in to have such a pipeline. Right? So, becoming an architect. So there's too much of this fluff, right? There's too much. There is design, there is principles, there is processes, there's dealing with people. How do you become one? What do you do next? Like, after you leave this room, what are you going to, besides swear at me and write bad feedback, what are you going to do? So I thought it would be really bad if I don't have code at least on one of my slides. So this is my algorithm for what you need to do when you walk out of here. Of course, read books as well. But seriously, the problem I have is when I wanted this as a full-time career, I found myself traveling, talking to people like Martin Fowler, like Eric Evans. I found myself reading their books. I needed to get mentorship. There was not enough in the books on videos that will just cover everything. In fact, there is nothing that you can study in university which says, you're going to graduate as an architect or have all the skill sets that you require as an architect in the real field. Maybe that will change one day, but today it's not available. You need to find yourself a mentor. You need to find yourself someone who's willing to spend the time to actually teach you out of his experiences. Eventually, you'll become better than them. Final advice, you want to be an architect. And I want everyone to tell me if they've experienced this before. How many people asked you to build a framework for your company? No frameworks? Okay, I'll tell you what. Whoa. So, we do that, right? We're going to start a new application. We're going to start a new company. We're going to start something new. Let's build a framework and solve all our problems before knowing what they are, right? Do not create frameworks. I can literally beg you not to create frameworks. Your job as an architect is not to create a framework. If you're a coding enthusiast and you think you can go out there and create something like Enterprise Library, Angular, you want to create something like Knockout, you want to create your own Signal R over sockets, by all means. Just don't start a project within your company by creating a framework. There are enough frameworks out there. There are enough components and helping classes and utilities and whatever you want to refer to these things are. As they're all out there. Get them, collect them, put them together. I'm sure you'll find your solution in there. All right. Well, you'll end up like this guy. All right. Actually, raise of hands, how many people here actually wrote their own frameworks at some point? I should have asked this before the slide. All right. This is another problem. We need to all avoid this. I have a very simple problem that requires a very simple solution, but that would be boring. I have 2 databases or 2 classes that need to exchange data. Let me go out there and buy Bespoke. All right? I have 2 services that need to share the one database, although some people might frown on that. Instead of creating schemas, I decide to create it in 2 different technologies so that by that, it'll never happen again. I have some non-functionals. I just need to log some methods and, the inputs and outputs. Let me go create an AOP framework from scratch. And the last one would be, as much as your applications change, so will the trends, so will the buzzwords, so will the complexities. But the only thing that will not change is the basics in which you solve these problems. When I say here, you can't, or not me, Albert Einstein said, you can't use the same thinking to solve problems with the same way you created them, is because we left basics. The reason we created all these problems is we followed the buzzwords, we followed the MSDN articles blindly, we did Stack Overflow development and said if the community is doing it, I should do it, without any science behind anything. All right? And I'm 8 minutes early. More question time. There you go. Feel free to ask questions, run away, do whatever you want. Any questions? Oh, sorry. Yep. At the very beginning. So the solution architect in an ultimate world in an optimal world, would be there when you're requirements gathering. In fact, for people who run Scrum, In projects I'm involved in, I usually create something called the architecture iteration and the development iteration. And the architects usually start much earlier. So they will be usually at least 2 sprints ahead of the development iterations. But again, whether the Scrum guys agree to that or not is another story, but the architect should start as early as possible. Sorry? Would you see that architecture stream and that architecture work running the entire project? Yeah, absolutely. So just like there's iterative development, there is iterative architecture. The reality is when requirements change in the middle, you're going to change it. The reality is also you will not leave the architect there for 2 months until he designs the entire system and then start development. So yes, architecture becomes as iterative as development is. The only problem with architecture is that if you don't build your designs to respond to change, that iterative architecture becomes really problematic. It becomes really hard to do. But if you're following good principles from day one, and you're responding to change, you're basically decomposing your components using volatility, all of that sort of stuff, absolutely. Yes? How do you force them? Here, I've got a whip in my bag. I'll give it to you after we're done. So there are multiple answers to that, and multiple techniques I've used personally. Number one is the one from Valentine's slide earlier, love. Convince technical people. Come up with something across your team that says, listen, this is how we're going to discuss a new technique. This is how we're going to discuss new technologies. Part of you being an architect is you mentoring your developers, you teaching them stuff. So while you're teaching something like CQRS, right? And I and my team internally now use CQRS all the time, and at the beginning I had all the usual defensive mechanisms. We've never done this. We always did, customer service, and it had all the CRUD operations, and we were good, right? Now, you have to find convincing techniques to basically tell them why this would change their life. So for example, let's take specifically CQRS. I basically told developers, let's do a comparison. Let's create a customer in the database with and without CQRS. So the old way, I'm customer manager, and on it there's a method called create customer. And we did exactly the same with the command and command handler. Next, I asked them, I said, okay, now I want to wrap this operation in a transaction, right? So what do? They go in and they change that method, right? And they wrap it inside a transaction scope, right? By that, they know that they've violated the open-close principle, right? On the CQRS side, a transaction decorator on top of the handler. And now you can reuse it with many other interface. Without even defining a new interface, you can use it with many handlers. Now show them that. Show them the benefits. There is no forcing here. You can't create a TFS rule that basically says, this code is not CQRS friendly, right? You have to show them the benefits. And trust me, when technical people see the benefits, they'll like it. One of the most defensive things I get about event sourcing and CQRS, but Omar, that's a lot of code. And my answer to that is a lot more simple code, a lot more simpler classes is better than one complex one. And show them why that's a problem. Get a scenario where you have a complex class. Get a scenario where you've got simple classes. Create that scenario and put an intentional bug in there. Give it to the developers. Fix it. And watch which one comes first. All these exercises, they bring about team bonding. They will strengthen your credibility. And it will also show people that you're not doing this out of blank. You're actually following some kind of science to it. Right? But I'll also give you the whip anyway. Yep.
I have a bit of a similar question, but from the point of view of stakeholders. So how do you, I suppose, your company specifically does
you start creating analogies that have nothing to do with the technical world. So the question here is, how do you explain to stakeholders how important design and architecture are? And you can't go to them and you say, that's because CQRS is going to make your components more modular. That's going to mean nothing to them. But what you can do is say, okay, would you, Mr. Stakeholder, go and buy a piece of land and engage a construction company to build your land? Would you let the bricklayers in day one to lay down the bricks? Or would you involve a civil engineer? Or would you like to see a blueprint of what that building might look like? Maybe you need to do some changes before they start. And let you know, construction engineer is much more rigid than what we've got, right? So, why are you doing the same thing with software, right? It even gets worse with software development managers. You know, they come and say, you know what, everything we did last year did not work for us. We need to be more agile, we need to do Scrum, we need to design stuff properly, etc., etc. And you think to yourself, wow, they finally get it. I'm going to go and do exactly that. I spent 2 months doing blueprints and designing. He comes to you and he goes, okay, the deadline has changed. It's now, next month, and we have to rush again. And you end up doing the same mistakes again. All of this stuff needs to come with communication. But my problem is this, right? I don't want you to take this the wrong way. But part of the reason I left the corporate world is because I learned how to say no. Right? Now, no got me very far. No got me very far. I was the chief architect of a multinational that was making millions, right? At some point, someone will come up and no just won't fly anymore, right? And that's when you know, well, you got to make a decision. Do I operate within an environment where I know we're going to fail? Or do I fight this no till the end? Or let's talk about the other option outside. So, yeah. Yes? So you can basically have automated tools that look at code. So the question is, are there any automated tools to know that developers are doing the right thing in terms of code, et cetera? Am I correct? So code, yes. Design patterns, architecture, no. Right? Microsoft attempted to create architecture tools, which basically you created rules around assemblies not calling each other. PostSharp, sorry? Layer diagrams. PostSharp created aspects that, although a class can call another class in .NET very simply, but if you put these aspects on top, you can control what class or what module can call what other module, assembly, or class. The problem I found is education is much better than enforcement in that case. When it comes to design and architecture, you can enforce, for example, who uses an underscore in their variable or not. But you can't enforce good design. Well, at least not yet. Hopefully one day we'll get an AI bot to one of these cognitive services where I can upload my UML diagram and say, please tell me, is this correct? That hasn't happened yet. Yes? Yep. Sure. Now, I'll take that question in general about standardization because I get that a lot. And the answer to that is you standardize on your science, on your practice. You don't standardize on the tools, on the solutions. Every problem is different. Every company is different. The people in it are different. The stakeholders are different. What you standardize on is you can, for example, say, you know what? For my projects, I'm going to use domain-driven design. I'm going to use CQRS. I'm going to use event sourcing. I'm going to use these tools as in my toolbox, right? But my problem with standardization when it suddenly goes haywire and you get a consulting company creating a CodeSmith code generation template. and think that that's going to work for everyone. Right? So find the balance. Find the balance. Your toolbox needs to have a lot in it. You need to be doing event sourcing, but you also need to be doing relational databases. You need to be doing object-oriented programming, but you should be very aware of procedural and functional programming. You need to be doing domain-driven design, but you also have to know what what active record and transaction scripts mean, right? It's that toolbox that you carry with you. It's at that point, that's your only standard. At that point, when the customer gives you his requirements, you basically go into your bag of standards and pull out whatever tool you need. But to say that you can come up with cookie cutter solutions for everything, I'd say if you do that preemptively as a consulting company, you'd be digging yourself a bit of a problem. Yep.
In regards to communication, do you think there's, I'm not sure how to put it, like, I've seen a lot of architects spend a lot of time trying to communicate to sort of non-technical people who sort of have an inherently waterfall sort of way of thinking. They like to have project plans, deadlines in advance, etc. And architects spend a lot of time kind of battling communication between those people rather than doing design or code or something. Is that just part of the job, or is there, how do you manage that?
Do I get my 33% of design on the project?
Well, sometimes no. Like, I mean,
Well, if the answer is no, then we need a much bigger solution. Now, regarding the communication with stakeholders about, for example, waterfall and Scrum and that sort of stuff, I don't know if I'm being mean here, but I don't find architects, well, many architects who know how to actually communicate with stakeholders. I find architects who rock up in a room and they will expect like whatever they say should come as common sense to the person in front of them. That's not true. That's not true even with humans, right? I can't come and speak to you about biotech. I've been reading about biotech for let's say 5 years, and I come and talk to you about biotech, and if you don't know something, I'd be surprised to say, how come you don't know this? And I find that that's the problem. There is always a way to communicate to stakeholders. Use analogies. If someone says, you know, Scrum is not working, I don't like the Scrum, you can't give me a fixed budget, right? And waterfall is the way I'm used to this stuff. Maybe a simpler approach would be, instead of pushing Scrum, maybe you should go and say, okay, let's take that waterfall project, and it's just going around, right? Take that waterfall project, split it into smaller projects, and do it that way and deliver functionality. So for all intents and purposes, you're still doing iterative development, you've just phrased it another way, right? I find that that's a problem with communication. But if that is taking away from your time to get your 33% of design, then that is a problem. Then you're not doing the core of your job anymore. All right?
So if that is the case, is there a good solution, or is it time to start looking? Like, are there dedicated roles essentially translating between those teams, etc.?
Okay. So for people who are doing domain-driven design, I said we come up with this thing called the ubiquitous language, and yes, sometimes there are the role. They call them PDMs in big enterprises, like product development managers, and they kind of talk to the stakeholders and then, you know, come down from the big shrine in the sky and talk to the technical guys. So yes, you can have that role. But again, if that role fails to communicate it, what are you going to do? I mean, unless you guarantee me that all that role is going to be employed, all the people employed in that role are psychologists and they can perform hypnosis, there is no guarantee, right? That's my problem. So if you do fill that role with someone who's going to go and translate, how do you guarantee that they're going to get the job done? That's the problem. And it's an ongoing problem. There is no silver bullet for that one either. I said I like the power of saying no. I find myself walking away from a lot of engagements because simply I can't get my message across. Yeah, happened twice in 7 years. So. Okay, guys, I don't know how we're looking for time. All right, we've got 7 more minutes. I'll hang around here, guys. If you want to ask me questions, please feel free to come by. Please fill in your evaluations, hold off the swear words, and hopefully I'll see you next year. Thank you.